All right, what's going on? Fourth period. Sorry, I'm out today. I am at a leadership. I'm part of a leadership cohort, and we meet once a month for a year. And this is our last meeting. So I'm making this on a Sunday right now. I got some football on, knowing that I'm going to be out Thursday. And so for today, you can watch this video, and then it'll lead you into two different things to work on during class. This worksheet here, I'm hoping you downloaded this. If not, you can go to assignments, and in our week 6, it's going to be a worksheet that can be downloaded. I wonder if I've put it in there yet. No, I haven't, but it'll be here. You can download this worksheet, and then I'm going to update the textbook pages as well. So we're going to do some notes here on this video, and the notes are on the worksheet. So if you want to open this thing up, it looks like this. There's a graph, there's some fill in the blanks underneath it, and I'm really just going to use these next 12 minutes or so to talk more about linear functions. It's the staple of Algebra 1. It's again a staple of Algebra 2. We have to be able to take functions like this that have constant rates of change, and we need to be able to find their key features. We need to be able to find their slopes. We need to be able to graph them. And so we're going to talk about 6 things here. Talk about how to find the slope. Talk about how to find the Y-intercept, the X-intercept, the zero of the graph, the starting point, and then 2 things that are kind of new. We talked a little bit about function notation, and so we're going to talk about how to find f of 0 and what that means. And then we're going to talk about what about when the function is equal to 0. Those are actually 2 different things that we will talk about. So first, let's just look at this problem. We got to graph it. Y equals 1/2 x minus 4. Well, remember, this is in slope-intercept form. Y equals mx plus b. The m is the slope. So the slope is 1/2. And the y-intercept is the b. And so the b is -4. Okay, so our slope is 1/2, and our y-intercept, again, y-intercept. What is a y-intercept? That's where it touches the y-axis. So we're going to actually put our first coordinate on this graph at the y-intercept of -4. Boom. That takes care of that. And that way we can now use that point and draw a slope here. Slope is 1/2, which means, remember, rise over run. Up 1 and right 2. Up 1 and right 2. Up 1 and right 2. Or down 1 and left 2. Down 1 or left 2. So there, try to draw this as straight as possible. Not bad. There is our line. Let's do some labeling here. This is the y-intercept of 0, -4. That looks messy. We have a slope of 1/2, so let's start filling in these blanks here. Slope, which is m, is 1/2. The y-intercept, which is b, is -4. The x-intercept, where does it cross the x-axis? Well, that's happening like somewhere over here, so we might even need to extend it a little bit to get it to touch. So up 1/2. So the x-intercept, that's 6, this is 7, this is 8. Looks like the x-intercept would be at the point 8, 0. That is our x-intercept. X-intercept is where the line crosses through the x-axis. So x-intercept is the point 8, 0. And now let's talk about these last 4 things. The zero of the graph is just another name for x-intercept, and I want you to see that. Why is it called a 0? It's because the y is 0. So when they want you to find the quote-unquote 0, they want to know what x value causes the graph to be equal to 0, and that's the same thing as the x-intercept. So the 0 is also 8, 0. What was our starting point? Do you remember? What was the very first thing we plotted on this graph, the starting point? That's actually the y-intercept, -4. 0, -4. Okay? And then these last two things, f of 0 versus when is f of x equal to 0. I'm going to show you that up here in this space. Okay, remember, f of x, we could also write it like this, y equals mx plus b, or f of x equals mx plus b. Remember, f of x is just like a y. It's just kind of showing you, hey, what would the function be if you plug something in right there? Remember, that is our input. And then the output is whatever we would get if it spit something out at us. Like if we took the x, plugged it in, what would we get? For example, if we wrote this one, f of x equals, let's just use this over here, 1/2 x minus 4. If we use that, and they want us to find f of 0, so I'm going to, instead of an x, I'm going to put in a 0. So instead of an x, I put in a 0. And then I'm going to see what it is. So f of 0 equals, what's 1/2 times 0? Well, that's 0. What's 0 minus 4? That's -4. So f of 0 is -4. When we plug a 0 into our equation, it gives us out a -4 as the y value. So our 0 is y equals -4. And then it says, what happens if you set the function equal to 0? Well, that's slightly different. That would be this. That would be me taking this function here and setting it equal to 0. So 0 equals 1/2 x minus 4. And now I need to solve this, which is what we did last unit. I need to solve for x. So I'm going to add 4 to both sides, and I'm going to get 4 equals 1/2 x. How do I get rid of that 1/2? I multiply it by 2, so I get 8. X equals 8. So when we set the function equal to 0, we get x to be 8. So those are some key features. Slope is, kind of the steepness of the line, and it's up 1/2. The y-intercept is where the line touches the y-axis, which will be right there. The x-intercept is where it touches the x-axis, which will be over there. The 0 is another name for x-intercept. Starting point is another name for y-intercept. And then these two things are very close to one another, but they actually mean slightly different things. What happens if you plug a 0 in to the function versus what happens if you set the function equal to 0 and solve? I challenge you to rewind and hear what I just said again. And even if you don't want to do that, I'm going to say it again because it's important. These two differences. This first one is saying, what if we plug a 0 in for the x spot of the function? What y value is it going to give us out? Versus this second one is, what if we take the entire function, set it equal to 0, and then solve for x? Notice I got two different answers for that. Okay? I'm going to do one more of these. I think I'm going to do maybe one of the more challenging ones down here. Yeah, I'll do 15 because it can be a little strange. So I'll do 15. But I hope that you now can work your way through these and practice these terms, because you're going to hear me say all of these terms a lot next week. So let's look at 15. Y equals 4. Whoa. Y equals 4. That's not y equals mx plus b. What is that? We might need to shoot over to Desmos really quick to remember that if you ever have x equals and then just a number, that's either going to be a vertical line or a horizontal line. And then if you have y equals a number, that's either just a vertical line or a horizontal line. Here's the way we can test it. Y equals 4. For every single point, y equals 4. So I'm going to first go to where y equals 4, which is right here. And every single point, y equals 4. So this is the point 1, 4, y equals 4. This is the point 2, 4, y equals 4. 3, 4. So these are all of the points where my y value equals 4. And I think you can see what type of line that creates, right? It's a horizontal line. If you ever see y equals and then a number, it's a horizontal line. For example, if it was y equals -1, I would go down to -1 and I would draw this line. Okay? So y equals equations are horizontal. If it was x equals, that's going to end up being a vertical line. And you'll be able to practice that one on number 13, x equals 3. So I won't spoil that. So y equals 4, we graphed it. So what is the slope of that line? Doesn't have an mx plus b for us to really look at the slope. Let's find slope the way we did the other day. Let's pick 2 of these points and do y2 minus y1 over x2 minus x1. That's how you find the slope. So let's try it. Let's just pick 2 random ones. Let's pick this one, which is 1, 4. And let's pick this one, which is 4, 4. And let's try to find the slope. Okay? Remember, we subtract our y values first. So what is 4 minus 4? That's 0 on top. Then we subtract our x values. What is 4 minus 1? That's a 3 on the bottom. What do we get for our slope? 0 divided by 3 is 0. Horizontal lines all have a slope of 0. It's a perfectly flat line. The steepness of that line is 0. You with me? Okay, so that makes sense. What about the y-intercept? Well, that's where it crosses the y-axis. That's right there. That's at 4. What about the x-intercept? Is this line ever going to touch the x-axis? No. It's parallel with it. It's never going to touch, so there's not one. There's not an x-intercept, which means there's not a 0. Starting point, what was the first point we plotted? That was the point 0, 4. So the starting point was 0, 4. And now let's do our quick test. Let's plug a 0 into the function for x, and then let's set the function equal to 0. So if we plug a 0 in for x, do you see an x anywhere for us to plug into? This isn't y equals 4x where we can plug something in there. This is just y equals 4. So there's actually no place for us to even do what they're asking us to do here. So there's also none. There's never a spot where the function is equal to 0. Or where if we plug in a 0, there's not a y coordinate that it's associated with. And then lastly, set the entire function equal to 0. Now that we can do, because instead of y equals 4, well, wait a minute. When is the function equal to 0? Wait a minute. Wait a minute. I think I messed up. I did. I messed up. Perfect. You can see that I'm human. Even some of this stuff I get confused on. It won't even let me erase now. It froze. Not ideal. There we go. When is this function equal to 0? So we can look at the graph here and see. Here is this line right here, the x-axis. That's when the function is equal to 0. Like this is the point 1, 0, 2, 0, 3, 0, 4, 0. This is when the function is equal to 0. Since it never touches that, there's actually never a spot where we can have a y value of 0. See, basically this is saying, where is the y value 0? And then this is saying when the x value is 0, what's the y value? And that actually does happen. When the x is 0 right here, here's the 0 on the x-axis. Is there a y value that's associated with it? Yes, there is. It's right here. What's that point? That's the point 0, 4. So that's the point 0, 4. The x is 0, the y is 4. So this is saying when x is 0, what is the y? The y is 4. And I accidentally had those mixed up. Okay, so I have 15 seconds before this video shuts off. I will say I want you to practice these because it really builds your skills. Notice some of them have negative slopes, some of them have positive slopes, fractional slopes, It'll be great practice for you to go through and do what I did on number 1. And then when you finish this, you can get a jump start on your textbook practice and have a great weekend.